All right, another big part of what we developed was we got a web UI that reports the GPS accuracy, the current position of the drone, as well as a compass heading and an estimated speed, as long as a map with, that displays the waypoints as it flies so that you can keep track of the drone as it's going through the course. And you'll notice it's now taking off here on the west, and it's going to draw lines where it thinks it needs to go, which doesn't look anywhere near where it needs to go. So I'm going to kill that. All right, so instead of having it fly to the report location, which could be anywhere, I'm going to have it just execute the search portion, detect an image, and I'll show you that image that it detects. Okay, so it's going to take off, and it's going to start doing, it's going to go a little bit higher so you can get a better picture of the bottom. All right, because I don't want to run the risk of it flying away because of the GPS inaccuracies, I'm just going to real quick demonstrate the search portion. So it's going to take off, hang out for a little bit, go to a height of 1 meter. Not quite as high because it's... And I'm going to throw this under there. Okay, so it stopped and took down. So it's pre-programmed to find that color right there. But we could update the search routine to maybe search for metallic objects or something like that, which would be useful, and potentially capture multiple, a series of images rather than just one image.
Right now we need three volunteers. Okay, so we've got take off from there, move to there, take a picture, calibrate, move to there, take a video, calibrate, move to there and land. Okay, so two main parts to our effort. The first was to create a mission API using some of the automation libraries already available for the AR drone. So we created, or Dustin created as our main backend developer, created a high-level API to do approximately 11 different commands. And we could pick out the points. That's what we were doing out there. When the different folks went to the different locations, we simply double-clicked where they were standing. And that puts in a move to event. And this is basically the mission that we executed. After we put in all those different steps, we just told it to start mission and it kicked off.
We are Space Cadets. My name is Brian Warren. This is Murtaza Kamal. Our third and honorary member is Robin Cox. Early on we decided we wanted to do tracking and tagging of potential threats. The idea here is that we would be able to fly the drone or multiple drones around in an area, find faces in the crowd, save the images to, or either save it to the file system or send it to a server somewhere who's doing the hard crunching saying, yes, that's somebody we care about, no, that's not someone we care about. But then the drone could fly around, and a lot of times you could set up cameras ahead of time, but if it's an open area, there might not be enough places, or the cameras would be fixed, and someone who is a sniper would be able to go, okay, I've got cameras there, cameras here, I'm going to set up over here, they're never going to see me. But a drone would be able to fly around, spin, change altitudes, whatever, and try to find all the faces. Also, geotagged images, the drone knows where it is and can assign that location when it's taking those pictures. The stream of video is huge, so we really only wanted to go, well, don't take pictures unless you find faces. We don't know whether those faces are important yet, but as long as it's facing the wall, go ahead and start it. we didn't want it to fill up disk space or clog the network with files or images if they weren't important. So now it's taking pictures of the wall. So you thought there were ghosts, but now we can start to go see these green. So it actually identified him, and then it comes around. And, but basically, it's actually capturing more than one face. It only shows what it calls the biggest face in a box. And so it will do that, but it's actually taking pictures, it's actually setting files anytime there are any faces. And so we can look around in the files now and see that it's picking up more as it goes along. And it continues to pick up faces, and then we can come back and it'll only find the ghosts now. So that was the idea. And then these, we're saving them to the file here, but you could certainly stream them to a bigger server. If we were law enforcement, we would have access to the facial recognition database in their servers to be able to actually analyze these faces. And stuff like that, but I couldn't find a cop who would give me his law enforcement code to go in there and do that. So this is as far as we got.
We're missing two people, George Turner and Ben Muckham. They're across the road, click and a half away at Pulpit Rock. Could you slowly give a pan of where you're at? Okay, that's good. That's good. So as you can see, we tried to lengthen the range a little bit of what we can do with this. Our solution wasn't to take the Wi-Fi cloud that connects the controlling device and the drone and grow it. Instead, we thought, let's take the controlling device and marry it up with the drone. The top left, drone plus phone, strap them together. Always remain in Wi-Fi range. Okay? We control the drone through an Android app on the phone, relaying commands that come from a web server that also serves up the client interface. That goes over the public internet, hooks to the phone over the LTE cloud, and into the drone phone pair.
All right, so we're going to have two video feeds here.
Yep.
The video feed on the right is me and Ben doing a Google Hangout. So he's recording the action from his phone, so that's the Google Hangout. And then the video feed on the left is the video that the drone is actually outputting. So we were able to capture the video feed over that 4G connection. The initialize button is what initializes the connection with the drone. So I'm going to skip that, and I'm just going to do a takeoff. And it's there, and it's hovering, it looks like.
Okay?
Yep. Kind of. All right, I'm going to move it up a little. All right. I'm just going to do some basic stuff. There are buttons on the left that do some basic operations. We have a drop down here that has pretty much anything you can do, but really the main way to control this thing is with the keyboard. Right. So I'm just going to move it around a little bit, do some spin action, move up a little more maybe. Okay, so I'm doing some basic stuff here. What I really wanted to do was invite any of the judges that want to pilot this thing to go ahead and come on here and pilot it, and I'll walk you through it.
Can we
This is
George?
an opportunity of a lifetime. Amazon is putting out job recs that require 5 years of drone piloting experience to be able to even apply for that rec. I'm giving you the opportunity to pilot on
The garden.
We have Parker controlling the drone. He's just doing a few forward movements.
Go for it. You want George to stand out there?
Sure. So when you issue a go forward, does it just move forward a little bit, or is it like
It
a set
moves-
amount, or does
It sets the forward command that stays basically the way that the drone is controlled.
Climb in altitude!
Uh-oh.
Altitude!
All right,
Stop
stop.
receiving
There you
the.
go. There you go, that's better.
We tried rooting it, we tried
You're
different,
almost crashing to
all
George.
kinds
Come
of
on,
things.
come on.
What we did is put it in one spot.
Keep going up.
Okay.
Up. Build out a weed whacker.
So our first thing was to have fun and let the boys fly the thing and code. My son is in 8th grade, Brian's a freshman. Brian's got some coding experience already, my son had almost none. So it ended up being my son just flying and, you know, blowing it off a little bit. So he's not here, I can talk about it. Our initial first idea was to chase a laser. We recently got cats in our house, and so I've been playing with my cats and having it chase a laser, so we're trying to turn the drone into a cat. So the first flight's like everybody was in this conference room. That was, you know, a little sketchy. And then Brian took it home and did backflips with it. I don't know how many got to do that. That was a lot of fun. And Brian ended up building in the first week a very stable, good control system for us that just stayed hovered really nice. We got forward, back, ASWD kind of stuff, and we started trying to do obstacle courses that we were making up in our driveways and stuff and crashing like everybody. And Parker and I were focusing on the chasing the laser piece. It was a really nice thing because they had the drone. I would just use the web client or just the video on my laptop to just kind of chase a laser, and it was easy to develop code independently.
So let me just play that back. I'm going to load a command file. It's just going to do a small little demo. It's basically going to fly a box and go back and land, hopefully on the table. But we
might need somebody to stand over there.
To do something else. So just to keep it from
In case it just runs amok.
Oh yeah, they look pretty good. So we're going to kick it off just by hitting these buttons.
Yes. All right. We wanted it on the table, but
Yeah.
I pushed it too hard, sorry.
It's this one over here, this one, it's in the center box.
Okay, so we'll just try it.
There you go. Yeah, one right off.
Okay.
Use the right side.
Well, here we go. We'll try it on the blue screen. So you'll see that I can put the laser over here. I'm going to adjust it a little so it's in the front. And then here we go. I put a little red dot on where it's supposed to go and get centered on. And now it's centered. So I can move it over here, go over there. And this is doing left and right alternates. A little more. Right, so now I'm going to land. All right. So the second, I wanted to do that better. So I decided that what I wanted to do was do the angled slope instead of just left and right alternates. So let's give that a try. Alright, so I'll go out there. You go way over here. Alright, now I'm gonna land.
Heavily with Dan's description here of, I love how he says this, pimping ain't easy. Neither is finding an empty parking space in a packed parking lot. Circling, watching, find a spot, blah, blah, blah. One of the things that Dan was talking about was hey, let's have our goal will be, we'll use a drone to fly parking lots, and we will identify what the free spots are. And we'll have an app that just can be like, hey, what's the closest free spot to where we're at? I'll go grab it. Tell you where. And a variation of that too was, we didn't get to, was you drive into the parking lot, you've got your drone on the roof of your car, and you push the button, it takes off, it goes finds you your parking spot. Anyway, that would have been really cool. But general design is a single drone or a fleet of drones, and going out looking at various parking spots using OpenCV and just or even lesser capable stuff of just kind of counting pixels and looking for colors and stuff. But what we really gravitated to were, hey, let's use GPS. We'll have specified routes. We'll know parking lots via these routes. Once you start using Mavlink, it like takes over and it keeps you from using some of the other APIs and stuff. You can issue commands all day long, but it just ignores them. Whenever Mavlink has like gained primacy over your drones and some of the other stuff doesn't work right, so we never quite figured that out. We started out using YA drone, but there were a lot of conflicts there. We never quite got that working correctly with Mavlink, but we found that the Node.js stuff worked good, so we just started using the Node.js stuff, notwithstanding the Wi-Fi stuff where, hey, I would see the link go up and down Wi-Fi wise, and I think maybe that's why occasionally you just have your drone doing some hidden waypoints and then just completely losing its mind, flying off into never land. So, image processing. Brian Schill did a lot of work with. We took some representative pictures of parking spots, open, not open, shadows, stuff like that, and just went through and tried to understand what OpenCV, like with some of the edge detection algorithms and stuff like that, can do for us. And here again, I mean, you either go do some of that stuff, or you can just run your simple pixel counting routines yourself and get close to some of that stuff too. So this was our little part of the ISS parking lot that we decided we were going to use for our course. Well, anyway, that's the one. And I went this morning and basically walked that course with the drone, a la when I reran that mission. It was instead of flying around here. Yesterday, when we were flying our course with the course West laid out, we were kind of to the north of the error was about 30, 40 feet north of where it was. And today, when I shot this course and ran it, the error was to the south, and it was flying around over these parking spots. So I have no idea. We had a RESTful service that served up our parking lot database and a AngularJS web app that kind of, hey, pull it up and you can see which spaces and go, know which way to drive in the parking lot. Oh yeah, issues, broken helicopters and stuff, broken drones. This one night, we were out here and the Rafflecopter guys were out there testing theirs, and luckily they were, because Bonnie and I came out and we started flying a mission, and our copter flew right over all the cooling fans. It wanted to fly in there for, and a couple of guys were knocking it out of the way and knocking it out of the sky, and otherwise it might have flown off to Timbuktu, so that was good. But after coming back, tweaking code, playing around a little bit more, came back and it had this spectacular crash right into that fence. Our way forward, develop a robust and reliable software library. That's good. Sorry, Dan, just saw that one. Yes, I agree with that. Very, very heartily agree with that. Basically, look at figuring out a way to factor this Mavlink stuff. As good as it works for hitting waypoints, it doesn't matter because you can't rely on the GPS stuff. Software could be modified to work with existing parking lot security cameras. You know where they are, you know where your parking lot is, you do your image processing. But a tethered aerostat, because that'll keep that thing from flying away and losing its mind. Well, if it does, at least it can't be any further unless it breaks the tether. And then use the forward cameras with the drone for swarm-based security monitoring, or just fear monitoring, I like to call that.
All right, so my name's Tim Beerman. If you haven't met me, I was with Narwhal Vengeance. We had quite a team. We had Tiffany, we had Mike Scheid, we had Tim Porter, and Doug Allison over there. So I'm going to talk about kind of maximizing drone-derived intelligence. What's all the stuff that's coming off the drone, and what can we do with it? Quite honestly, we had a lot of fun with this drone, but it actually is a toy. So we weren't really super keen on spending a lot of time building something that only works with a toy. And you know, the little things in the videos we saw where they can control it and do this and do that, and it would go around and all those kinds of things or control it. We're really interested in the big picture. All of the drones that are out there, the entire spectrum, going up in the DoD from the Global Hawk on down to the tactical level, and then getting down into the micro drones. So what are the really big issues they're having with drones? First of all, just how do you deal with that much data? There is so much data coming in from all of these different platforms that it's really impossible to view all of it or even know that it exists. You know, us that work with Sydney, how many times has something happened and you wonder, hey, I wonder if we could go back in time and see if there was any footage or anything grabbed from this time frame. It's quite possible there was drone missions going on all over the place, but very few people know about it. It's nothing that's indexed, that's made searchable, that you can go out and find it. And it's quite possible even footage that was taken years ago could become invaluable if you could find it. So we're kind of curious on how to deal with that. And then once you have all of this data, how do you make it usable to as many people as possible, not just one analyst looking at the footage, but how do they take that and make it so that it's usable by others? You know, there's a lot been put into being able to automatically extract information, and that's good, but ultimately the best intelligence is going to come from somebody who's actually looking at the footage and can put something together, an intelligence report. Now the automation might be good at identifying areas that should be looked at, but we're kind of interested in once they do that, how can you write something up and make it searchable for other people? And then tactical exploitation. You know, at kind of, you know, the platoon level and even at the company level, how can they take some drones and start making them really work for them in a tactical setting? And then some virtual situational awareness. How can we take the products that are coming from the drone and make them just a little bit better and a little bit more usable? So we'll be going through all these things. So we'll start with the really large data. So fundamentally, we need to be able to index it so that we can find it, make it usable. Very simple. So how are we going to go about doing that? We're going to use Topic Builder to kind of demonstrate with our AR drone how the footage and the information that was gathered from that can be put into a system so that other people can find it and make it usable. So one thing that we did do programmatically in the AR drone is we wanted to be able to, when it's going out there flying, to be able to take images and geotag those images. So you get the GPS position, and you get the image, and you get the orientation. So as you're flying around, you can be rapid grabbing those things, and then you can look at those individual images, or an analyst can be looking at a whole segment of MPEGs, and then they can go in and look at very specific sections, and then extract that to do a report. So as an example, if I go in here and I will do a search for ISS, and I have one intelligent software solution observation. So I have one very small report, but there was a drone that was flown there on October 30th, which seems like a long time ago. And as I recall, when I was flying, it was very nice outside. So it has a little bit of information on what it is, but it also has the URL. Didn't have time to make it clickable, which would have been more convenient, but I can go to that. So what happened is somebody can write a report, we can look at the frame knows its location and orientation, so we can use that to go out and grab data from other sources. So here we're just using some simple ones. We have Bing, we have Google, some of those things. You can look at some open source imagery that's been taken around there. So somebody else in that area has already taken some imagery or some other product, you can actually find it. So it has Street View up there, pretty simple, but the idea then is this stuff came from a drone, just one idea of what you might be able to do with some of the drone data. So that's looking at ISS. So we can do some other searches. Like I was at Gossage Park and I smelled something funny. I do a search for that, I say, hey, something happened at Gossage Park and there was a strange odor. So what could that be? I'll go and look at the drone mission. So there you go, I can see there, but there's some teenagers over there on skateboards. Never know what that means, but it can mean a lot of different things. And then you can get, an overall, hey, there's a picture up there that's actually kind of very close. So what could that be? Some other kid on a bike looks to be about teenager-ish. Not quite as, you never know, but I'm not judging anybody here. But you can start putting things together. And you can think of all the ways that this can be put together. So is this happening in other parks? We can go and look in Colorado Springs, say, hey, is there any other parks with any imagery? And nothing came up. They have Gossage, but that's about the only thing that came up. Now I, as an analyst, actually know that there was a mission flown into the park. It just they didn't put in the proper information. It was at Cottonwood Creek, so I can go find that. All right, so now we have a Cottonwood Creek mission. And we also have some derived information that comes with that. So here's another mission. I don't see any problems here with any teenagers, but I do want people who are out there searching for parks, like Gossage Park, to be able to find this. So this is where some of the tools in Topic Builder come out. I can tag this. I can say, hey, put this in with parks and add. So now when I go back to search, you can see some of the tags, parks. I have to get rid of this, not just Cottonwood Creek. But if I search for park now, you see that it came up. So that's value-added intelligence after the fact that people using Topic Builder can add to a lot of the missions that are going out there flying. What about Guard of the Gods? Was there any drone footage at Guard of the Gods? Well, what do you know? I think there was some drone footage at Guard of the Gods. I'm sure I know who didn't take this drone. But if we go and look at this drone footage, somebody did. They did not get the memo. And I don't know if you can see any people that are climbing on the walls that got buzzed by this drone, but I don't really blame them for not being able. This is actually a pretty cool video. And if we had all those drones, and as soon as the footage came down, you automatically indexed it, and you extracted the path that it flew, put a little buffer around it. So if anybody goes into a map and says, I'm interested in this area in this time frame, they could tag that and find it and identify it. And then we're in a better situation to take advantage of all of the stuff that we're gathering that might not even be valuable to people that collected it, but could conceivably be valuable to other people later in time. Just a lot of cameras out there. So tactical. Some of the things that we wanted to do tactically with the drone. These are the smaller drones that you can put out there with that platoon level, maybe the company level. Tactical reconnaissance and observation. And this was interesting because it's actually real. Lethal miniature aerial munitions. So an example of a tactical engagement. I just use a tank because tanks are awesome. I used to be an armored crewman. And I don't brag about it much, so I'm going to now finally. But this could work very well for infantry or any soldier, because obviously the safest place to be when the enemy is over here is behind where they can see you. So with an Abrams tank, you're safest down here, but you can't see anything and you can't engage. You can sneak up so your turret down with a fire control system on the top, the gunner's primary sight. You can actually see what's out there. And then once it's out there, you can go up and engage. You got to get clear so the gun can get over there. This is comparing it to a T-72 that shows our spectacular awesomeness. They have to go way up here, and they're just chicken feed for an M1, where you can see that much of a T-72 is going to blast it. But even when it has to go up and look at it, you're still kind of exposed. And if you're infantry sneaking up there trying to engage, even more so. So, you talked about having a drone on top of your car, popping it out there to look for parking. We could deploy a drone right off there that could interact with the fire control system or what the gunner can see, so that before they even have to go over the hill, they already know where targets are at and can immediately engage. So, we're going to show kind of a demonstration on how that might look. this works. So this was one of our many missions that we ran. Tactical observation, what we're going to do is I'm going to simulate being an infantry soldier, and I want to look up over the crest of the hill. So I'm going to deploy the drone. It's going to rapidly spin around, identify me as friendly. So it's already been evaluated. Now it's going to go over here because we have this hill slope. I do not want to go over there and look to see if there's any enemy. But the drone can pop up there fine, and you'll see it's observing 2 targets that are off there in the distance where I'm safely ensconced down there drinking my coffee. All right, now, lethal miniature aerial munition systems. This is where we're getting into the creative portion of our presentation. So this is actually, I forget, the RFI is out there, but they basically want to be able to take drones and turn them into kamikazes at the tactical level. So you can send out small drones and they can kind of persist in the area, but they can engage individual targets. So we did that with our drone. Now we couldn't engage a person because I couldn't fool anybody into doing it. But we did simulate the mission. So this footage takes a little bit of time to get ramped up. Because you got to be careful. I mean, when you're telling a drone to kill somebody, you got to take your time and make sure that you know what you're doing. In this particular instance, this is going to be a directed assault, meaning that the soldier is actually going to give a command to the drone, and the drone will attack the target. Since we can't attack a person, we identified a tree that is going to act as our target. So as soon as I give the command, it turns around and attacks, boom.
Real life, folks.
Yeah, we couldn't show the end because the carnage was too much. But trust me, it took it out. All right, now, hardened structure attacks. A little bit different. You know, we're talking about tanks, personnel carriers, a building. You might want to go ahead and attack that. This got a little bit tricky. We needed some higher level of intelligence for the drone because it needs to make a lot of different decisions because this is autonomous. We're not telling it to kill something. It's going out and picking the target itself. So Tim Porter made a network called Skynet. It's a neural net-based artificial intelligence. It's going to be making the decisions for a drone in this particular instance. Skynet's been acting up a little though. It's doing some strange things lately. I'm not sure. It's probably nothing. But we'll go ahead and look at this. So Skynet, our second mission, the drone is going to go out there and start identifying the entire target area. As it is scanning through there, all this information to be put into Skynet. Skynet is going to be making the decisions on the best way to attack this particular target. And as soon as it's calculated and made its decision, the drone is sent directly at it. You'll notice that it's kind of going sideways. It's identifying the perfect way to enter the building. Going into the glass, not to break the glass. And that's how direct it. Did you hit the light? Okay. So that was Skynet control. Now, the micro-armored vehicles. So this is real. This came out of U.S. Air Force stuff. They're looking at having little tiny microbots that can go out there and engage individuals. This is kind of spooky, but it's actually, well, it's cool if we're there first. This is actually, the next one's kind of a strange picture. You can't show it really good, but this is kind of showing a sniper. One of these things sneaks in behind and identifies as a sniper, goes ahead and takes the thing out. Now, we're not the only ones developing these things, okay? So you can imagine that other governments are developing these kinds of technologies, so we need to be prepared to defend against these things. So the next mission, detect and attack, there's an enemy air micro vehicle out there that needs to be identified by Skynet and engaged. So this one's pretty quick. It picked up on it really fast. As soon as it gets spun up, what that was, there it goes, identified, the micro drone, took it out. So this was even more impressive than it looks because this is a stealth micro drone. I'm willing to bet hardly any of you actually saw it. But it was identified and engaged. So that concludes the creative portion of our presentation.